We're working on problem number 8 from our homework packet, and what we need to do is find the net resistance on the circuit above. And what's different about this problem is we have things that are connected both in series and parallel. So the first thing to account for is you need to understand what is actually in series with one another and what is actually parallel to one another. Okay, so how we determine that is where junction points are, and we know that a junction point occurs at the left and right side of this because there are pathways for our current to go through. Our current, when going in a conventional direction, can either take the upper route or our current can take the lower route. So that tells us when we do that, right, when we go around our circuit, those two different directions, that 1, 2 must be parallel to R3. Resistor 1, 2 is parallel to R3. Notice I didn't say R1 is parallel to R3 or R2 is parallel to R3 because the pathway starts before R1 and ends after R2. And because it's that entire R1 and R2, we have to consider them as a combo, okay? But what else we should find out here is on that blue line, we didn't have a break in our pathway. If we don't have a break in our pathway, that means that R1 is in series with R2. And that's all we really need to know in order to solve this. Because if we know those two things, we could use our rules for combining resistors in series and combining resistors in parallel. So we're going to first do the series part because if I want R12 with R3 in parallel, I need to know what is R12. So to figure that out, R1 is in series with R2. That's how I'll figure that out. So R12 is equal to R1 plus R2. So R12 is that 2 ohms plus 3 ohms. So R12 is 5 ohms. So that is R12. And if we were to reimagine the circuit, here's what it would look like. Where this is R12 and this is R3. Now they are definitely parallel to one another because of those two different pathways. So we'll solve that now to figure out what is the total. So 1 over R123 is equal to 1 over R12 plus 1 over R3. So 1 over R123 is equal to 1 over 5 ohms is what we just got, plus 1 over 5 ohms. So we get R123. To get this, we have to add our fractions on the right side. 1/5 plus 1/5 is 2/5. And we take the reciprocal, which is 5 halves, and 5 halves is 2.5 ohms. I want you guys to try 9 as part of your work today. I think you could definitely manage to get that without my help. So just consider what I told you and do that. But we are going to do, I'm going to show how we do number 10. So it says find the following on the above circuit. So find the equivalent resistance between 1 and 2. So 1 and 2 are parallel to one another. So to do that, we're just going to do, and let me write it down here. So for part A, 1 over R12 is equal to 1 over R1 plus 1 over R2. Okay, so 1 over 2. And we get 1.2 ohms for R12. Please show your work for this. I'm just doing this quickly because I want to get to the important parts. Find the equivalent resistance of 4, 5, and 6. So that's 10, 2, and 5. Okay, so 1 over R4, 5, 6 is 1 over R4 plus 1 over R5 plus 1 over R6. And I get 456 is 1.25. It's really, really important that you do this in your calculator yourselves, just so you know how it's working. Okay, so let me just talk about what happens next. So R12 is 1.2 ohms, R456 is 1.25 ohms. Okay, so what happens next is if R12 has become a single circuit and R456 has become a single circuit, what happens is R12 must be in series with R3, which must be in series with 456. Because again, if we imagine this as one single resistor, R12, it start to end, it goes through R1 and 2. So that's the quote one resistor. Then goes through R3 and then goes through 456, which is that quote one resistor, and then back to the battery. All right. So this is on the next slide, but I'm going to have to reference back. So it says find the current through the battery. So to find the current through the battery, I need to figure out, well, what's my net resistance? And my net resistance here is, again, um, and this is part C. I skipped that, sorry. My net resistance will be the resistance of the battery is equal to R12 plus R3 plus R456. So 1.2 plus 7.55 plus 1.25, and I get 10 ohms. So R at the battery is 10 ohms. Now, the question that I skipped to after I skipped over C was, what's the current? So the current through battery, if I have voltage and resistance, I can use Ohm's law. So if I'm the current through the battery, I take V over R to get I, which is my current through the battery. That's 12 volts over 10 ohms is equal to I. I get I is equal to 1.2 amps. So my current at the battery is 1.2 amps. Now, what this tells us that's so valuable and so important is if that's 1.2 amps, that means everywhere in my circuit that's on this pathway is 1.2 amps. So that means that the current going through 1 and 2 total is 1.2 amps. So I know then that the current at 1 and 2 is 1.2 amps. I also know then that the current going through 3 is 1.2 amps. Because that current splits off at 1 and 2, but then it comes back together right before R3. It comes back together right here. So when it splits off into whatever and whatever, it'll come back and reform at 1.2 amps at resistor 3. And then again, at 4, 5, and 6, the total current, I456, must be 1.2 amps. And how that's going to help us is twofold, because now not only do we find the current through these combo resistors, but these resistors are connected in parallel with one another. And if they're connected in parallel with one another, the voltage is the same everywhere, because we have a rule that says if our resistors are parallel, the voltage will be equal to the total voltage. So to get the voltage, say at 1, 2, to get V12, I take I12 times R12. I get 1.44 volts. And then what happens next is we know that at V2 it must be 1.44 volts. And we know that V1 must be 1.44 volts. because again, that the voltage when in parallel, the voltages must be equal to one another. So if we did this for 4, 5, and 6 to figure out what the voltage is, we take the 1.25 times 1.2 and we get 1.5 volts. So that means that the voltage, and I'm running out of room here as you can clearly see, that V4 must be 1.5 volts, V5 must be 1.5 volts, and V6 must be 1.5 volts. Okay, and then you could figure out V3, and then the last thing that you need to do for this problem after you figure out those voltages is figure out the current running through each resistor. So I'll leave that for you guys to do on your own. Let me know if you have any questions. I hope that this was helpful. And if you're stuck, just shoot me a message and I'll be sure to respond to you. Okay.